Okay, we've made it past question number 7. Let's move on to question number 8. Question number 8, what is the slope of a line parallel to the line y equals 1/3 x minus 2? Now remember class, we have reviewed the slope-intercept form of a linear equation, and we set that up as y equals mx plus b, and m is the slope and b is the y-intercept. And the only thing we care about here is the slope. So if the slope is m, then in this equation the slope here is 1/3. So let's think about a parallel line. We know that parallel lines are defined as lines with the same slope. So if parallel means same slope, and the slope of this equation or this line is 1/3, then the slope of our parallel line has to also be positive 1/3. Question number 9. Well then, what is the slope of a line perpendicular to y equals negative 2x plus 5? We've learned, class, that perpendicular, and I'm going to use the symbol, perpendicular means slopes are opposite reciprocals. Opposite reciprocals. So let's take a look at this equation. We know the slope is where the letter m is in our equation, so the slope is right here. So the slope of our existing line is negative 2. That means, we want to rewrite that. Let's rewrite that as a fraction. As a fraction, the slope is equal to negative 2/1. 2 is the same as 2/1 as a fraction, and we know that to get the opposite reciprocal, we will do two things. We will change the sign, so instead of being negative, now it's positive, and then we flip the fraction. It was 2/1, and now it's 1/2, and that is going to be a positive slope. So the slope of our perpendicular line to this equation, which has a slope of negative 2, is any equation with a slope of positive 1/2. Question number 10, if I can find it. Question number 10. Let's go get to that now. Here we go. Question number 10. Use the figure below to answer questions 10 through 13. Units are in yards. Let's remember that in case we have to answer a question about perimeter or area. Alright, there's our figure. It is a quadrilateral. It has 4 points. And the question number 10 says, what are the coordinates of points A, B, C, D? Now, I'm pretty confident that most of you know how to do this. Some of you are still struggling, but I still see lots of mistakes being made. So once you find the coordinates, please go back and check your work to make sure you didn't make a mistake. So point A, I'll start with the origin. 1, 2, 3, 4 on the x-axis, positive, and then positive 1 on the y-axis. So A is at positive 4, positive 1. Okay, B. B is at 1, 2, 3, positive 3 on the x-axis, negative 2 on the y-axis. So B is at positive 3 on the x, negative 2 on the y. C is 1, 2, negative 3 on the x-axis, negative 2 on the y-axis. So C is negative 3, negative 2. And D is 1, 2, negative 2 on the x-axis, 1, 2, 3, positive 3 on the y-axis. So D is at negative 2, comma, positive 3. All right. Now at this point you should be checking your work. I've already done this work in advance, so I'm pretty confident those answers are correct. Let's continue on. Question number 11. Find the length and slope of each segment. Well, length is just distance, and slope we know how to find. Let's go ahead and figure out the lengths of each side first, and I'm going to pick off the easy one. BC is a horizontal line, so I can count that. 1, 2, 3, 4, 5, 6. BC, I know, is 6. And what's our unit of measure? I think it was yards. Let's take a look. Yep, 6 yards. I can abbreviate that YDS. Okay, now every other line on this shape is a diagonal line. It's not vertical, it's not horizontal. That means I have to use Pythagorean Theorem. I'm going to crank through these pretty quick. Let's go ahead and figure out the length of AB. AB, if you look at my Pythagorean Theorem, I'm going to make a right triangle. It has a leg of 1 and a leg of 1, 2, 3. That means it's going to be 1 squared plus 3 squared equals c squared. 1 squared is 1, 3 squared is 9, so 1 plus 9 equals c squared, and that means 10 equals c squared, so c is equal to the square root of 10, which is approximately 3.2. So my value, or my length for AB is, that's right here, 3.2, approximately 3.2 yards. Let's go ahead and do DA. So DA, I'm going to make a right triangle, and I'll put it up here. I can still fit one more calculation here, looks like. DA, I've got a leg of 2. It's going to be 2 squared plus 1, 2, 3, 4, 5, 6 plus 6 squared equals c squared, and that's going to be 4 plus 36 equals c squared. 4 plus 36 is 40, so that means c is equal to the square root of 40, which is approximately, take a look here, approximately 6.3. So DA is approximately 6.3 yards. And my last one is DC. Let's do that one in, what color do I have? Let's do that one in purple. So DC, I've got a right triangle here. And looks like DC has a leg of 1 and a leg of 1, 2, 3, 4, 5. So 1 and 5. I'll move down here a little bit. Let's go ahead and calculate the length of DC. DC is going to be 1 squared plus 5 squared is equal to c squared. That's 1 plus 25. 1 plus 25 is 26. And that means c is going to be equal to the square root of 26, which is approximately, I think that's 5.1. Yep, it's 5.1. So the length of CD is 5.1 yards. Now class, if this question was asking you for perimeter, all you have to do is add these numbers together, but we're not being asked for perimeter. The next thing we're being asked for is slope. Now remember class, slope is just rise over run. Rise over run. Many of you are still having difficulties with this, especially with positive and negative numbers. Let's go through this. The slope of AB. AB. Now I can use the same lines that I used for the Pythagorean Theorem. I can either go from B up and over to A, or from A down and over to B. Let's go from A down and over to B. Well, from A down to B, to go straight down, is negative 1, 2, 3. So we've got negative 3 as our rise, and negative 1 as our run, which ends up being a positive 3 over 1. Because both are negative, negative divided by a negative is positive. Does this line AB or segment look positive to you? Yes. From left to right, this slopes up. It's uphill. It is a positive number, so the slope of AB is 3 over 1. Now, the slope of BC, that's easy. We know a horizontal line, the slope of a horizontal line is 0. That one's done. How about the slope of CD? Let's use the same markings we used for Pythagorean Theorem. From C to D, I'm going to go up 1, 2, 3, 4, 5. So our rise is 5, positive 5. and our run is 1. So our slope of CD is 5 over 1. Can't simplify that, so we're done. And then the last one, DA. Now you can start from D or start from A. It makes no difference. I'm going to start at A. We go up 2, so positive 2, because we have an actual rise, not a fall. But then we have to go left, which is negative on the x-axis. 1, 2, 3, 4, 5, 6. Left 6, so negative 6. And this can be reduced, class. This can be 2 divided by 2 is 1. And 6 divided by 2 is 3, and don't forget it still remains negative. So that slope is negative 1/3. Does that make sense? Take a look at DA. From left to right, as we're moving along from left to right, yep, sure enough, if we go left to right, hit D, we start going downhill. So we know that DA must be a negative slope. In fact, let's just label that here just to make sure we're getting this. This will be a negative slope. This will be a positive slope. This has no slope, and this has a positive slope, and that matches with our numbers. So we've got question number 11 done. Let's take a look at question number 12. Which pairs of sides are parallel? Explain how you know. Well, parallel means same slope. Take a look at our data. Are any of these slopes the same? We've got 3 over 1, 0, 5 over 1, and 1 over negative 3. None of those slopes are exactly the same, and that means we have no parallel lines. Which pairs of sides are parallel? No sides are parallel, and I'm going to use a symbol for parallel because all the slopes are different. Or you could have put because no slopes are equal, but I'll just put all the slopes are different. So I proved that there's no parallel lines because there are no slopes which are the same. Let's finish this up and take a look at question number 13, which is on the other side of the column. Question number 13. Which pairs of sides are perpendicular? Explain how you know. Well, we know that perpendicular sides have opposite reciprocal slopes. Let's take a look. 3 over 1 and 0, those aren't opposite reciprocals. 3 over 1 and 5 over 1, those are totally different. Those aren't opposite reciprocals. But take a look at the top one and the bottom one. 3 over 1 is the slope of AB, and negative 1 over 3 is the slope of DA. So that means that AB and DA have to be perpendicular because their slopes are opposite reciprocals. Let's take a look at AB and DA. AB and DA. Sure enough, that sure looks like it's a right angle. We prove now it's a right angle. So for this question, I know that AB is perpendicular to DA. AB is perpendicular to DA because they have opposite reciprocal slopes. Now, let me write this for a second. Opposite reciprocal slopes. That's your proof. Please don't say, yeah, they're perpendicular because they're adjacent. Being adjacent has nothing to do with perpendicular. AB and CB, or AB and BC, they're adjacent, but this is not a right angle. And BC and CD, that's not a right angle. And we also saw CD and DA, that's not a right angle because there's not opposite reciprocal slopes. So class, give me your conclusion. I know that AB is perpendicular to DA, and then give me your evidence because they have opposite reciprocal slopes. That should be slopes. All right. We'll move on to question number 14 in the next video.